Assalamu alaikum wa rahmatullahi wa barakatuh. So I'll present uh, a brief description of the project that I've been working on. So first, let me start Q ground control. Okay, and then we will launch the software in the loop simulation. We have our drone over here. We will launch the micro DDS to connect between gazebo and ROS, so we can get our topics. Now everything is connected. We'll put this on top. We will follow the drone. And I'll launch the script of training, our DQN. And the model is taken off progressively until it reaches 20 meters. We have our over here the terminal takeoff progress, and when it reaches the range of 19.7 and 20.3 between them, we will have the model restart and try to keep in that range. You see the oscillation over here. When it reaches the range, it restarts the gym environment and the model starts over again. Now to have a look at the code. Let's have a look at the code. The view. So I use train agent. It uses drone environment, which is this one. We initiate the drone environment, and we will use the DQN model, which is a discrete action space. In this task, I made some constraints because I saw that the drone would flip every time the thrust increased a lot. So I put the thrust in this interval, 0.4 and 0.78. The velocity between -3 and 3. And the Z position, normally the drone would be in this range. The reward zone is this one, as I said previously. And we have our hyperparameters for the model. And finally, some code to save the model, our final model, and to have some checkpoints. And the tensor board. Now for the environment, the main part of this code. So we use these RCLPy for ROS and PX4 messages, which is a package that is used to get the offboard control mode, which is a topic in ROS, trajectory set points, vehicle command, and vehicle odometry. So this is the initiation of the environment. This is the obstacle. This is for obstacle detection. My bad. This is the one. It uses approximately the same thing. Just there is no image here. Well, in the obstacle environment, there is an image that we need to observe, that the model needs to observe. So the environment parameters, we have the observation shape, which is the position x, the velocity, and the thrust. Every time the drone is at a certain position, I need to get the position, the velocity, and the thrust. The target altitude, which is 20 meters, as we said previously. The different constraints. So the drone wouldn't flip. We have the action space, which is discrete action space. Zero. When we have zero, we decrease the thrust. One for increase and two for restart. Our publishers, we publish for the off-board control mode. So Q-ground control would understand that there is a control other than the manual one. Trajectory set points to have the drone at the specified altitude, and the vehicle command to publish to the different motors. The subscriber will subscribe to vehicle odometry to get a different Z position, velocity, and the thrust. State variable, these ones, off-board active, is armed or not, and the drone velocity and position. I have a callback loop, timer, and odometry. This function is to publish vehicle commands as to increase thrust, decrease, and all that. I use this to have to debug, to see the different states of the agent with the environment. This is the reset function for the gym environment, but it doesn't work with the gazebo because it didn't do it here. I will be doing it in the obstacle navigation. And we have the reward function, which is this is before the step function, where the drone makes the agent makes the different actions of the environment. The counter we will increase by 1, and every time we will apply velocity, and we will handle the restart and apply to the different the actions between 0, 1, and 2. The reward function is calculated with the calculate reward function, which is defined here. We will extract every time the drone position, and if the drone is in the range that we talked about earlier, we got a reward of 1. Else we got a reward of 0. Here we will check the terminal episode if the episode is terminated or not, if the drone hit the ground, or we reach the specified altitude. This function is to get the observations from the environment, the position and velocity, and the thrust. And this function is to destroy the node, Control C, from the terminal. I have over here the obstacle navigation. This is what I'm working on lately. And train navigation, I'm using a PPO because I need to work with a model which is continuous action space, unlike the DQN, which is a discrete. These are the different hyperparameters. Now to finish, I made a model. I made a package where I'm using all of the 8. So I'll try to activate soft on the loop, the micro DDS instead of ROS because micro DDS is more rapid and more precise, while Mavros is a little bit old, and I try to use that different and more a newer software. DRL. It should work now. Let me activate the bridge. And this is the UAV camera detection package that I'll be using for object detection and obstacle avoidance. Receiving video frame. And this is the detected frame from the camera topic. If I initiate it, let me arm the drone. And as you see in the detected frame, we have the blade rotating. And if I take off, you can see the frame is changing, and this will be used to avoid obstacles and dynamic and static obstacles. Maybe I think of using a LiDAR and a depth camera. And I guess that's it. Thank you for your time. Assalamu alaikum wa rahmatullahi wa barakatuh.